Okay, for our next quiz, which is chapter 6, we have 3 sections. In these 3 sections, 6.1, 6.2, and 6.3, I just want to give you a visual before we start practicing for our quiz. Now in 6.1, you'll see I have ratios, rates, and unit rate. So we're going to have 3 of those type of problems. Now when you're working with your ratios, the ratio will be written such as 1 to 2, which you can see here. Now to write that in fractional form, you take the first number and that is your numerator and the second number is your denominator. And just like we've learned in chapter 4, you just need to make sure that this fraction is in simplest forms. Now when we work with rates, it's the same thing except for it has a unit attached to it, which are the same. So we have 4 gallons to 1 gallon. So this is a ratio, but it's written with gallons, so it's a rate. And we're going to show you how to use these problems where, again, all we're going to do is write it as a fraction and make it sure that it's in simplest form. Now, lastly, in 6.1, what you're practicing is unit rates. When you have these unit rates, these will be our division problems. So when you're taking your quiz, these are the words you're going to look for, and these are the notes. Whenever it's a ratio, it's going to ask you to write it as in fractional notation in simplest form. Same with rates. It's going to ask for it to be written as a fraction in simplest form. And then when it comes to a unit rate, and you can see it's written as a fraction, but it becomes a division problem like this. So I'll give you some examples of that. Now in 6.2, we have proportions. Now proportions are just ratios that are equal to each other. And we're going to use a method which, and you can see the yellow arrows, we're going to be cross multiplying. So the first set here, you can see we have 2 ratios, and we're just going to cross multiply to see if those numbers equal to each other. And that's when we're going to deal with a true or false condition. It's going to ask you, is the proportion a true or false solution? So I'll give you some examples of that. And then over to the next one right here, we have 8 over 15 equals x over 6. Now the other part of 6.2, we're going to have to find the unknown. But we're going to use the cross multiplication method there too. And so that's what you have to look for when you're on your quiz. Whenever you see this word proportions, you think to yourself, well, you know it's going to be a cross multiplication problem. What do I need to do? Am I finding the unknown, or do I have all my numbers and I just need to solve the problem? Lastly, 6.3 is taking these proportions and deriving information out of a word problem. And the methodology is that when you set up your first ratio, if you have miles on the top and inches on the bottom, when you go to the other side of the equation and you're trying to find the other known, make sure that you're consistent with miles on the top as the numerator and the inches in the denominator. And we'll go through examples of that. Let's start working on something that is a ratio problem. So you can see in this 6.1.1, write the ratio as a ratio of whole numbers using fractional notation, and write the fraction in simplest form. So there you go. They're asking for this ratio form as a fraction, and then make sure it's in simplest form. So that's an example. Now let's go ahead and do one on the board. So if we had the ratio, which is, say the problem reads as 66. We have 66 women and 60 men. Now they're letting you know, and this is 66 women and 60 men in a school marching band. And they want you to find out the ratio of women to men. So the ratio of women to men. So the women, 66 women to 60 men. That's in fractional notation. And I can see it's not in simplest form. So we're going to use the breaking it up in factors, which we've learned in previous chapters. And I know I'm not changing the value, I'm just changing the appearance, because 6 times 11 is still 66 and 6 times 10 is still 60. So I know that these 6's, they divide out to 1's. So my final answer here would be 11 over 10. So that's the correct answer. Now, let's go ahead and try another one. How about if we have a ratio that's written as 30 to 70, and they want that written in fractional notation? Same concept. The numerator, the denominator, and then make sure it's in simplest form. We're breaking it up in factors. And we know 10 times 3 is 30 and 10 times 7 is 70. We know that 10s divide out to 1s. So our final answer here would be 3/7. And that's your final answer for your ratio. Okay, now how about if we have one that is written like this? 2, 8, and 1, 10. Well, we know the first number is our numerator, the second number is our denominator, but I'm just going to go up to the margin and I'm going to go ahead and make sure I convert those to mixed numbers. So in this 1/10, remember 8 times 10 is 80 plus 1 is 81, and you never change the denominator. So now I'm going to use those numbers. So I have 9/2 in fractional form, just like that, 81/10. And remember, we've learned in the previous chapters that becomes a complex fraction, and that's the same thing as writing as 9/2 divided by 81/10. And we also know that we have to go ahead and convert that to a multiplication problem, and we take the reciprocal of this number. So we flip it. Okay, and now that I have it written out like that, I'm just going to break it up into its factors. So let me get rid of this to get that out of the way. Set of equals. Now I'm going to break this up as 9 times, and I'm going to display 10 as 2 times 5. And then on the bottom, I'm going to write 81 as 9 times 9. So now I can see the 2's divide out, my 9's divide out, and my remaining amount is 5/9. So there you go. That's in fractional notation in simplest form. So we had to start from this, and then we went to this approach, then this approach, which enabled us to get here to the simplest form. So these are all just writing out ratios and fractional notation in simplest form. All right, so let's go ahead and try one more. So this one here has a decimal in it. And they want us to always use whole numbers. So we're going to set it up first. Now, you say to yourself, the digits beyond the decimal point to the right, it's in the 10th place. We only have one there. Since it's in the 10th place, we're going to multiply it by 10, which will enable this decimal point to move over one position. And what you do to the top, you must do to the bottom, because we're not changing the value. We're only multiplying it by a value of 1. It's just going to change the appearance, which will give us 21 over, and then 10 times 10 we know is 100. And then you don't have to do anything further because that is in simplest form. You're not going to get a 21 out of this 100. So you can't break up those factors in any other way. Okay, now we have a word problem. It's with a ratio where you're going to recall this from your homework, where it has a triangle and the problem reads a right triangle shaped billboard. And it's going to give you these measurements of 5 feet, 12 feet, and then 13 feet. Now, it wants you to find the ratio of the longest side. So put the longest side. Okay, well, first what we have to do is make sure we come up with our perimeter, which we add up all 3 of these. And when we do that, we end up with 30. So that's our perimeter. Now, our longest side is right here, the number 13. So we take this 13, which is the longest side, over top of our perimeter, which is 30. And then that is our ratio. But don't forget, it's feet. 13 feet to 30 feet. So that is your final answer, because we can't reduce it down any further, because 13 is a prime number. Now, a special type of ratio is a rate. And we have this problem, right? Rate as a unit rate. And rates are used to compare different kinds of quantities, like you see here at 511 riders and 7 subway cars. So let's write that, 511 riders to 7 subway cars. Now, if you plug that into your calculator, you're going to end up with a whole number, which is 73. And how you finish writing that is, because when you put 511 divided by 7, you end up with an answer 73. And it's 73 riders per subway. And that's the final answer there. Now we're going to work with finding a unit price. And this unit price, it is just a rate, but it's a rate expressed as price over top a number of units, meaning the price is in your numerator and a number of units is in your denominator. So just think of this when you see a unit price problem, think of it as a division problem. So on in your homework and on your test, you're going to be given a problem similar to this. So you have two different type of crackers. One is $1.39 for 6 ounces, and the other one is $1.89 for 8 ounces. So you'll have a 3-part question. Now the first part will ask you to come up with this unit price for the first cracker. So it's just a division problem. So if we do the first one, it would be 139 divided by 6 ounces. So it would be the price per the ounces. And when you plug that into your calculator and pay attention to your instructions, it'll tell you how many places to round it to. In this particular problem, they wanted to 3, so the answer would be 2.32 per ounce is a unit price. Now the second set of crackers, it would be $1.89 over 8 ounces, and we plug that into our calculator, and then we would come up with 2.36 per ounce. That's our unit price. Now the third step of the question would ask you, okay, well, let's go ahead and let's compare these numbers and let's see what would be the best bang for your buck. So meaning, getting more for less. So if you look at it, we see the first number, it's only $0.232 per ounce, and this one's 0.236 per ounce. So we can see with these last digits, this is higher. So this one right here is your better buy. So the $1.39 for 6 ounces is your better buy. So we would say that this one here would answer number 3. That's your better buy. Now the next keyword to look for when you're taking your test, you would look for the word proportions, and this relates to section 6.2 and 6.3. So there's 2 ways we're going to express proportions. Well, not express, we're going to solve using cross multiply. And in some questions, we're going to determine if the portion is true or false, or we may look for an unknown. So let's go ahead and give one a try. So if we have something like 15 over 7 is equal to 3 over 2, and then we're going to use a cross multiply method to see if this is true or false. So the first thing we're going to do is we'll take one of them or 2 of them. It doesn't matter. So we'll take sorry about that. Let's take the 15 times 2. And when you plug that into the calculator, your result should be 30. And then when we plug 7 times 3 into the calculator, the result should be 21. So if we write that would be 30 equals to 21. And that is not equal, so that would be false. Those ratios are not equal to each other. Again, a proportion is a statement that states whether 2 ratios or rates are equal. So even though these look a little complex, remember here is our fractional notation. This is still a ratio written with our number in the numerator and our number in the denominator, and we want to see if they're equal to each other. So this one is a little bit more work, but we're still going to perform the cross multiplication method, and we'll just do this little by little. So starting this one, we would start multiplying it out. So I'm going to take one at a time. So if I have 5 over 2 times 14 over 25, and if I start reducing that down, I'm going to rewrite that as 5 times 2 times 7. 2 times 7 is 14, and then 2 times, and then 5 times 5 is 25. We can see that this reduces divides out to 1. These divide out to 1. So my answer here would be 7 over 5. And if I do that again with the next set of numbers, if I have 45 over 5, and it's multiplied by 1 over 6, and I start breaking 45 out as 5 times 9 times 1, and then on the bottom just write out the 5 times 6, and you can see the 5s divide out to 1. that this right here, I originally wrote 44